Now, if we have a graph of displacement and we've got some sort of curved section that we want to analyse, then there's four basic possibilities for what's going on with the velocity and the acceleration. Now, remember that velocity is the first derivative of displacement. So if our section of graph of displacement has a positive gradient, which both of these do, then we can tell that the velocity must be positive because the displacement, don't forget here if we had something on these axes, this would be time and this would be displacement. We can see that as time goes along, our object is getting further and further away from the origin, or the value of it is going up. And in both of these cases it's going up, and we can tell because the gradient, if you slap your pen on the graph and just have a look at it, the gradient is positive. It makes sense also then that if the velocity is negative, then the gradient of the displacement graph will also be negative. So we've got two possibilities again, with a negative gradient looking like this or like this. And in both cases, the displacement is going down, okay? Now, the concavity is always given to us by the second derivative. And in this case, acceleration tells us what's happening with the second derivative. So you'll notice that in both of these scenarios, even though one has increasing velocity and one has decreasing velocity, can you see how the curve is concave up in both of these? And that's really logical if we consider that positive acceleration should be associated with a positive concavity or a concave up in the graph of the displacement. When acceleration is negative, that graph of the displacement, because this is the second derivative, should show that it is concave down in that section. So we get these four basic situations where we've got something that's, the displacement is increasing and it's actually increasing at an increasing rate. Or it's increasing, but the rate at which it's increasing is actually decreasing. So the take-home points, a graph of displacement, if you want to find the velocity, look at the gradient. If you want to find the acceleration and see whether it's positive or negative, look at the concavity. But anytime you're confused, just come back to those basic definitions, that the velocity is the change in the displacement over time. So if the displacement is becoming more positive, then the velocity will be positive. And if the displacement is becoming more negative, then the velocity will be negative. Similarly, acceleration is the change in velocity over time. So if you're struggling to work out if the acceleration is positive or negative, just say, well, what is the velocity doing as we move along through time here? Is the velocity getting to be a bigger and a bigger number? If so, our acceleration is positive. And if the velocity is getting to be a smaller and smaller number, our acceleration will be negative. Now, there's a few confusing things that come in because we've seen that velocity can be negative just because we're moving away from the origin. We might be moving along a number line into negative numbers. And the fact that the velocity is negative does not mean that we're slowing down. In fact, acceleration being negative doesn't mean that either, because we can be in negative numbers and we're just looking at the change in the velocity.